Good morning, my YouTube viewers. This video is going to be the last video about hypothesis testing, and the next video we'll be talking about some other tests that we're going to perform. But this particular video is going to be about lunches, and we're going to cover a practice question. So a university is thinking of having a new lunch facility. If 70% or greater students want the lunch facility, then the university will adopt the new lunch facility. We're going to perform a one held left z-test. The null hypothesis is P is greater than or equal to 70, and an alternate hypothesis is P is less than 70. So what we're going to do is we're going to write a program in Python to answer this question. And in order to execute the program, what we're going to have to do is we're going to have to import three libraries. So we're going to import NumPy as NP. And NumPy is a numeric library that performs numeric calculations. It creates NumPy arrays, and it creates distributions. We're going to import scipy.stats as stats. So scipy is Python's scientific library, and stats is a statistical module within scipy. And then we're going to import matplotlib.pyplot as plt, and that is a visualization library. So now what we're going to do is we're going to set up our parameters for this program. So population percent is 70%. Sample percent is 0.68. So you can see right now that the sample percent is 0.02 less than the population percent. Sample size is 750, and your alpha, which is your significance level, is 0.05. So we're going to calculate the standard error of the proportion. So standard error equals np.square root population percent times 1 minus population percent divided by sample size. And that equates to a value of 0.01673. And then we're going to print the standard error as well. Now we're going to calculate our z-score. So your z-score equals your sample percent minus your population percent. So that's going to be negative 0.02. divided by your standard error, and that is negative 1.1952. And then we're going to calculate our p-value. So your p-value is calculated as stats.norm.cdf z-score. So norm indicates it's a normal distribution, and CDF is cumulative distribution function. The out, we're going to print the z-score and the p-value, and then we're going to analyze the p-value. So if the p-value is less than alpha of 0.05, you're going to reject the null hypothesis because the sample proportion is significantly lower than the population proportion. If the p-value is greater than or equal to the alpha of 0.05, we're going to fail to reject the null hypothesis because the sample proportion is not significantly lower than the population proportion. So we're going to plot this. We're going to plot a standard normal distribution onto a chart. So x equals np.linspace brackets -4, 4, 1000, and y equals stats.norm.pdfx. So norm indicates it's a normal distribution. PDF is your probability density function. We're going to plot the standard normal distribution. plt.plot brackets x, y, label equals standard normal distribution, color equals blue. We're going to shade our critical region. So critical value equals stats.norm.ppf alpha. So norm is your normal distribution, and ppf is your percentage point function. And plt.fill between brackets x, 0, y, where x is less than or equal to critical value, color equals red, alpha equals 0.5, label equals critical region. So we're going to mark the z-score on the plot, plt.axv line, brackets, z-score, comma, color equals green, comma, line style equals dashed, comma, line width equals 2, comma, label equals z-score. So we're going to add titles and labels to the chart. The title is a one-tailed left z-test. The X label is z-score. The Y label is probability density. And you're going to get a legend. And then we're going to show it. So you can see your standard error is 0.01673. Your z-score is negative 1.1952. Your p-value is 0.1160. And since the p-value is greater than the alpha of 0.05, that means you're going to fail to reject the null hypothesis. The sample proportion is not significantly lower than the population proportion. But the sample proportion was lower than the population proportion. Let me just see how much lower it was. Sample proportion is 0.02% lower than the population proportion, but it still failed to reject the null hypothesis. So now we're going to look at the chart that we've made. So the blue is your standard normal distribution, your red is your critical region, and your green is your z-score of negative 1.2. So the z-score is just slightly before the critical region, but it's still within the normal region. So that means that the null hypothesis, they're going to fail to reject it. And that concludes this particular video. It concludes the list of practice questions on hypothesis test. And so the next one, we're going to be doing a section on difference in means. So I hope you decide to watch those videos too.